Hello everyone, I'm Akito Shibata from Hiroshima University. Today, I would like to talk about category-oriented sentiment priority dictionary for rating prediction of Japanese hotel. The outline goes like this. First, I'll explain the research background and our objective. After that, I'll introduce our methods and show the experiments. Finally, I'll give a conclusion. First, I'll explain the research background. The hotel booking sites provide reviews and category ratings. Category ratings are often more important than reviews because ratings are intuitive and easy to understand. Moreover, we can see quickly. However, problematic reviews and rating pairs exist. For example, there are categories that don't have ratings, and reviews and ratings don't match. So, this study considers predicting ratings for each category of hotels from reviews as a solution. This would allow for weekend supplemental category ratings that don't have ratings, and we can alert if there is a discrepancy between review and ratings when the review is written. Related research includes several methods using sentence vectors. By these methods, each sentence is represented by a fixed length vector. For example, bag of words, first text, but, and so on. However, by such vectorization methods, it is difficult to extract positive and negative degrees of each word. So in our work, we propose a method for extracting positive and negative degrees of words. We propose combining with existing vectorization methods to improve precision of the rating prediction. In our method, we construct a sentiment priority dictionary for extracting positive and negative degrees of words. Sentiment priority value SPV is a value to indicate how much the word is complimenting or undermining. In general, the more positive the value, the higher the value, and the more negative the value, the lower the value. A sentiment priority dictionary (SPD) is a table summarizing SPV for each word. SPD is used to apply the SPV to words in a sentence. Then we can predict ratings from the scores of each sentence. For Japanese, there are some representative SPDs which are widely used in the field of Japanese natural language processing. However, there is a problem with the existing SPDs. That is, the SPV for each word is always constant. But we think the SPVs of the words may vary for each category. So, our research objective is making category-oriented sentiment priority dictionary (CSPD). CSPD has different sentiment priority values for each category of words. For example, delicious has a high value in the meals category. I'm going to explain the method now. First, we focus on the appearance rate of words in the reviews. We found that the appearance rates of words in the reviews vary greatly depending on the category and the ratings. Therefore, we decided to use appearance rates for the creation of the CSPD. I will now explain the methods using WAN reviews as an example. First, we split the review into review sentences. We split words and sentences by reading marks and periods. We use Janome for this purpose. This tool is used for Japanese morphological analysis. Next, we categorize the review sentences into categories using the category dictionary, which summarizes what category the words are describing. Then we combine the review sentences into a category tag by a category. We call that sentences category review. Category review is fill the class field based on the ratings for the category. In the example, basis ratings is 5 and means ratings is 4. So basis category review is classified as a basis ratings of 5, and meals category review is classified as a meals ratings of 4. In the following, we call category reviews simply. Next, we'll explain how to calculate the SPV based on the classified reviews. Let X be a category and Y be a rating value from 1 to 5. Then, let Rxy be a set of reviews with Y in X. The calculating SPV is based on the appearance rate of words in Rxy. The appearance rate UXY of word A in Rxy is UXYA. UXYA is calculated by this formula. The appearance rate of word A in all ratings in category X is called UXA. UXA is calculated by this formula. In addition, we also calculated the appearance rates for all words. We call it UAVE. Based on the values obtained so far, we calculated polarity score SXA. SXA has a higher value the more A is used to complement, and a lower value the more it is used to despise in the category X. After calculation of polarity scores for all words, we calculated the deviation from SXA based on 0 for each word. In our CSPD, this is used as the SPV. The CSPD is completed by summarizing the calculated SPVs into a table. Next, we will explain how to find the features using CSPD. Let's take the basis review I mentioned earlier as an example. First, we fit the SPV based on the basis category in CSPD. Next, we calculated the average of the SPVs in the review. This is called the Sentiment Polarity Feature, SPF. This is a feature of the review. We consider review ratings prediction as a classification problem. We use logistic regression as a classifier. I'll show the experiments for evaluation. In our experiments, we compare the RMSEs of each category's ratings predictions. Then we performed a 5-cross validation for comparison. RMSE is the square root of the mean of the sum of the squares of the difference between the predicted and reviewed ratings. The smaller the value is the better. Training dataset is Rakuten Travel's 2004 to 2015 review dataset. Test data is Rakuten Travel's 2016 to 2019 review dataset. First, we compare the CSPD with existing SPDs when we use only SPFs by each dictionary to predict the ratings. The results produce the best precision in all categories. Next, we combined SPFs with existing vectorization methods to predict ratings. We use BART as the vectorization method. BART is currently the most popular sentence vectorization method. The results showed that the combination of CSPD was more precise in all categories than BART alone. I'll give a conclusion. We make sentiment polarity dictionary for each category suitable for hotel reviews. Experimental results show improved precision over the existing sentimental polarity dictionary. It is also more precise when our sentiment polarity features are combined with existing vectorization methods. As a future work, we would like to predict ratings for subcategories. Subcategory is subdivision of each category. That's all. Thank you for listening.